Lesson 5, Financial Applications Involving Exponential Functions. So our goal is to solve problems that involve loans and mortgages by using our exponential functions. So during the diploma, again, the only formula you're given is this version of it. So we need to be able to take our information from our finance questions and put it into this formula. So the first part, why? Well, if you remember from any exponential that we've done so far, this is always your future value. It's what's going to happen. It's going to be how much money will there be after this amount of time, how many bacteria will be after this, what's the population going to be in the future. So y is always the future. A, because A is our y-intercept, it's always our starting point, our initial value. This is our initial value. How much money did we first invest? How many bacteria did we start with? What was our starting population? This is also sometimes called the present value. B is the tricky one because it depends on what type of exponential function we're dealing with. So if we're dealing with appreciation or growth, then to find our B value, we have to go 1 plus whatever our rate of growth is. We always want to make sure that this is written as a decimal, divided by what's called our compounding period. I'm going to abbreviate CP. So the compounding period tells us how often they're going to be giving us money. So for example, our interest might be compounded monthly. So every month they're going to give us a little bit of our money. So if my interest rate is 12%, I don't get 12% per month. That 12% is for the entire year. So that means I get 1% added in every month, so that by the end of the year, I get my total 12%. So that's why we always have to divide by the compounding period, because we need to know how much money they're putting into our account at a time. This also affects what we put in as our exponent, because this is how many compounding periods. So we don't just put in X, we have to put in our compounding period times by our variable. So whatever we divide by up here, we need to multiply here. So appreciation ones are the annoying ones. Depreciation are a little bit simpler. So if I depreciate, or if I have decay, well, my B value just becomes 1 minus whatever my rate of depreciation is. Again, we want this as a decimal, because we always want to write our formula as what we're going to keep. So if I depreciate by 10%, I get to keep 90% of my value. I know that might be a little confusing right now, so let's try a couple examples. We're going to focus first on the tricky appreciation. So we have an example here, and I kind of gave you a little cheat sheet of the information that we need to look for. So I'm just going to kind of highlight as we go. So an investment of $500 is earning an interest at 6% per annum, compounded semi-annually. They want us to do two things. Write an exponential function that represents the amount of investment AT in dollars after T years. And then part 2, they want us to then use that equation to determine approximately how many years are necessary for the investment to double. All right. So first part, we're going to fill in our cheat sheet. So the initial value, my initial investment, well, that was the $500. Future value, well, they want us to double. So I have to double my $500, which means I need to get $1,000. My compounding period, it tells me we're compounded semi-annually. Which means I get money twice a year. My interest rate is 6%. We always need that as a decimal, so we're going to divide it by 100, which is going to give me 0.06. And because I'm trying to figure out how many years, this is what I'm solving for. All right, so the first part, they want us to write the exponential function. So AT is going to represent my future value. And T is going to represent time. So my equation is going to be AT equals my initial value, because remember that's what goes in for A. All right, so this is an appreciation. So I have to go 1 plus my interest rate divided by my compounding period. So I have to go 1 plus my interest rate divided by my compounding period. And remember, whatever I divide by down here, I have to multiply by up here. So this is going to be 2 times by my time, which is T. I'm just going to simplify that inside. So if you wanted to do that on your calculator, you would just go 1 plus 0.06 divided by 2. So I can simplify this equation as AT equals 500, 1.03 to the power of 2t. Okay, so that was part 1 of our question, where it says write an exponential function. Part 2 then wanted us to solve for how long it takes for us to double. So we're going to solve for the time it takes for AT, our future value, to equal 1,000. So I'm going to put in 1,000 for AT, which is going to equal 500, 1.032 to the power of T. So this one, because we have a bad base here of 1.03, obviously solving it algebraically by finding a common base is going to be rather annoying. So we're going to solve this with our calculator. So we're going to put the left-hand side of our equation into y1, and we're going to put the right-hand side of our equation into y2. So y1 I'm putting in 1,000, y2 I'm putting in 500 times 1.03 to the power of 2x. Remember, our calculator always puts an x, doesn't make a difference. All right, so obviously my window here, I'm not going to be able to see anything because my 1y value is all the way up to 1,000. I'm not sure how many years this is going to take, but hopefully it's less than 25, so I'm going to put 25 as my max. Sure, let's count up by 5s. Y min, well, let's say I start off at 0. And my max, we know we have to be bigger than 1,000, so let's put in 1,500. I'm going to see if that's enough. All right, so I can see my intersection. So again, we should jot down our window. I should change my scale if I'm going up to 1,000. Let's count by, say, 100. Actually, let's do 150. From 0 to 1,500, counting up by 150. And then we want to doodle a quick sketch. So I have a graph coming out like this, a graph coming out like this, and we're looking for that intersection. Okay, so we're going to go second calc, 5, enter. So we get that x equals 11.724 ... years. So remember, we want to end with our sentence. So we would say it will take about 12 years, because obviously 11 years isn't enough. So 12 years for the investment to double. And there we go. So that is the second part where we figure out how long it takes the investment to double. So again, you have to remember this. You have to be able to brain dump this on your formula sheet. All right, so here's another example here. Carly wants to stay ahead of the rate of inflation, so she decides to invest $1,000 in a financial product that is paying more than 2% interest. Her financial advisor also presents her with 3 different products that can earn compound interest. The compound interest is calculated at the end of each year at the rates of 3%, 4%, and 6% respectively. So you can see that's what they have here. They want us to determine again how long will it take Carly's investment to double. So if I think in terms of my formula, well, my initial value, they give that to us. That's going to be my 1,000. And if I'm doubling, that means y, my future value, is going to be 2,000. And what I'm looking for, again, is the long. So it's my t, that's a question mark. Because I'm appreciating, my b value is going to be 1 plus my interest rate. This one, we're just compounding yearly, so we don't have to worry about adjusting for that compounding period. So this first equation is going to be, well, we know y is 2,000. So we're going to have 2,000 equals my initial investment of 1,000. 1 plus, remember we have to divide this by 100 to get the decimal, to the power of t. There's no need to adjust for the compounding period because it's just 1 year. So we're going to have 2,000. I'm just going to simplify that inside again. 1.03 t. So we're going to go over here. I have 2,000. And I have 1,000, 1.03 to the power of x. Again, my window obviously not going to be enough because my y max only goes up to 1,500. So let's boost that up to 2,500 and see if that's enough. All right, I can see my intersection point So second calc, intersect, enter, enter, enter. There we go. So T equals 23.449. So approximately 24 years. Again, 23 years isn't enough. So even though we would mathematically round down, we still have to wait for that 24th year's interest to be dumped in before I will have double. All right, so the only thing different between part A and part B is that we're changing the interest rate. So we're still going to have 2,000 equals 1,000, 1.04 to the power of t. So we are going to put that into our calculator. So the only thing we have to change is change this 3 to a 4 and graph it again. Calculate our intersection. So we get that t equals 17.67, so approximately 18 years. And again, only thing changing is our percent. So going back in and changing that percent, graphing, and intersection. So t equals 11.895, so approximately 12 years. All right, so this is a your turn. So first try it on your own and then come back and see how you did. So this one, there's two different ways to complete it. Way one is by doing the regression. And way two is using our information about this. So for a regression, and my apologies, I do have these backwards. So this is actually our y value, and I'm going to go into list 2. This is our x value. It's going to go into list 1. So we're going to go stat. We're going to edit 0, 1, 2, 3, 4, 5. List 2. 2507.29, 2514.60, 2521.94, 252929, and 253667. Okay, so we're going to turn back on our stat plot. And we're going to make our window. Let's keep it 0 to 25 just in case of the next question. And I'm going to make this actually 3,500 only because I can see in the next question they want me to go up to 3,000. And let's count up by 500. So let's jot that down here. 0, 25, 5. 0, 35, and 500. Alright, so we're going to go back into stat, calc, exponential calc. Store in our regression into y1. And there's our regression. So we get y equals, we're going to round to 2,500, and it's going to be 1.0029 ... All right, so for this one, we look here and we see our initial value, how much I started with, is 2,500. So we go y equals 2,500. B value, we have 3.5% compounded monthly. So because we're appreciating, written as a decimal, compounded monthly. So there's a difference in our B values in these ones. It's because this is just X and then this is the 12X. Both of these equations will give you the same answer in part B. I'm going to use the regression one just because it's what's in my calculator. So remember Y1, we're going to put our regression. Should already be stored there. 0, 0. And Y2, we're going to put in 3,000. So I can see that's already stored there. So let's put in 3,000. I can see my X isn't big enough. I got to go bigger. Now I can see my intersection. Second calc intersection. So X equals 62.6 months. So she will reach $3,000 in about 63 months. All right, another your turn. So again, try it yourself, come back and see. Okay, I have a A value, I'm appreciating, and I have a compound of semi-annually. So Y equals 3,000. 1 plus 0.035, my rate as a decimal, divided by 2 because I'm semi-annually, and adjust my time for that as well. Again, always whatever you divide by here needs to be multiplied up here. We can simplify this if we want to, figure out what is that. So 3,000, 1.175 to the power of 2x. So we want to reach $5,000. This is our new future value. And I'm looking for my time. So 5,000 equals 3,000, 1.0175 to the power of x. Again, we are going to y1, y2, and find that intersection. So obviously, again, I'm going to have to up my window because I'm not going to be able to see 5,000 in that. So let's say I have x, 0, 100 going up by 5s. Y is 0, 5,500 going up by 500s. Let's see if that's enough. I can see my intersection. Again, we want to doodle our graph. So we got a very casual line. We get I forgot to change my y1. So clear. Okay, y1 5,000. And this one we want 3,000, 1.0175 to the power of 2x. All right, there we go. So let's just adjust this. So we have and we're looking for intersection. So again, x equals, so reach $5,000 in about 15 years. All right, so now we're going to do an example with depreciates. Thankfully, depreciates is a little bit easier. So Matt bought a car for $2,500. The car depreciates approximately 15% of its value. Again, this is kind of a two-parter. Write an exponential equation to model the decay. And then they want us to use that equation to determine the value of the car in 10 years. All right, so we know we have an initial value of 25,000. We are depreciating. So I'm going to go 1 minus our percent as a decimal. And there's no compounding period or anything like that. So our equation just becomes initial value, or b value, to the power of x. All right, so that's our exponential equation, part 1. Part 2 now wanted me to figure out how much value the car is going to have. So that's determine y when x equals 10. So we're just going to throw that into our equation. So let's go over to our calculator. 25,000, 0.85 to the power of 10. So the value of the car at this point is $4,921.86. So in 10 years, the value of the car is $49,021.86. See, depreciation, much easier. All right, here's a couple more your turns. So pause the video, come back and see how you did. All right, so Jack bought a camera for his studio 2 years ago. His accountant told him that starting from the beginning of that second year, he can claim a depreciation rate of 20% for the camera as a business expense. At the beginning of the second year, the camera is worth $2,000. How long in years from the time of purchase? Remember, this is always our x value. Will it take for the camera to be worth only $200? So our original equation, y equals, well, our camera was initially worth $2,000. We're depreciating, so 1 minus our percent as a decimal. So let's simplify this. Wants us to figure out when we're going to equal 200. Okay. Just going to quickly plot my stat plot off. Okay, so y2 or y1, y2. So we have 2,000, 0.80 to the power of x. Okay, I'm going to change my windows a little bit because obviously I have too much x. And, well, my initial value was only 2,000, so let's put that in there. There's a much nicer looking graph. So again, 0, 25, 0, 2,500. Let's make our doodle. So we're depreciating only 200. Find our intersection. So x equals 10.31. So in 11 years, the camera will be worth $200. All right. Sarah inherited a set of rare silver coins from her great-grandfather. An appraiser told Sarah that the coins are currently worth $1,000, and their appreciation, so this is going to be a 1+ situation, rate will likely be 25% per annum. Thankfully, no compounding interest, so we don't have to worry about that part. Determine the equation of the exponential regression function that models this situation. Well, we have our unknown future value, our starting value of $1,000, and because it's appreciation, it's 1+ our rate as a decimal. So again, I'm going to simplify that. There we go. So how long means I'm solving for an x. In years will it take the coin to be worth 2,000. So that's my y. So we're going to have 2,000 equals 1,000, 1.25 to the power of x. Now, if you don't want to deal with these big numbers, again, you don't have to. You can do it the way I've done it in every other examples. But you can get rid of the big numbers and just say that 2 equals 1.25 to the power of x. And again, these are not nice numbers, so we can't do common bases. But now this is my y1, this is my y2. So I'm going to just reset my windows because I've been having some wonky windows. So now my y1 is 2, and my y2 is 1.25 to the power of x. See, I didn't even have to change my windows because I simplified it down. So my x is -10, 10, 1, and my y is -10, 10, 1. So I'm going to go second calc, 5, enter, enter, enter. Oh yes, make our doodle. There, x equals 3.106. So in about 3.1 to 4 years, the camera the coins. I'm still doing the last question, sorry. Years the coins will be worth $2,000. All right. So this here is a good thing to know. These are your compounding period numbers. So they tell you what you have to divide your interest rate by. And this is the formula that we're doing. So you can see we have future, present, and our I is calculated by going annual interest rate divided by our CP. The problem is this is not on your formula sheet. So that's why we were just focusing on the y equals AB to the power of x and how to create that in these types of situations. So you just have to be able to brain dump this onto your formula sheet so that you have it. And there you have it. There's all of exponential functions. Good luck with your homework.